Hey everyone! Today, we're going to show you new updates already available in the Pit Optimizer. We added new diagrams to visualize the initial data in a graphic form for better clarity. We also added an option you can use to make a decision on the pit boundary for mine planning. The proposed final pit boundary has a marginal profit of close to 20%, but only the user makes the final decision. Moreover, we added a feature to record the affiliation of each block, with the final boundary to a field of the block model. To do so, select a field for recording and get the result. We also added exclusion zones, but we'll show that a little later so as not to reset the calculation results. We did a lot of work on the capital cost calculations. We can now divide them into two categories: those that affect mining operations and those that don't affect mining operations, but change economic performance. The first category includes the relocation of buildings and other objects in the open pit area. The second category includes the replacement of equipment, etc. By setting a boundary in the open pit area and assigning a cost to it, we can more accurately determine the set of blocks that will be included in the final result, because these costs affect the pseudo-flow algorithm. Both capital costs are displayed in the final total for each boundary respectively. If the cost of mining in the specified area is high, the algorithm will assess this and leave this rock mass in situ. Profit should be greater than costs. Let's continue working with the capital costs, but from a different point of view. For scheduling, one part of the capital costs, which are not fixed to the location, is determined by the user according to the mining periods, and the other part is determined automatically for the period of time when the area is involved in pit mining. If we look at capital costs in terms of pushbacks, their accounting algorithm is similar to scheduling. The part of the capital costs not involved in the space is defined by the user with affiliation to each pushback, and the other part is accounted for automatically. You can disregard it and look at NPV without additional capital costs, but the costs assigned to the area will be accounted for automatically. The same approach works for both auto pushbacks and manual pushbacks. Please note that, like other indicators, capital costs are displayed in the accumulative, differential, and incremental data display modes. For additional economic analysis, we expanded the functionality by adding the sensitivity analysis tool. Here, we can enter the indicators we want to estimate, the estimation range, and the step, and make the calculation. The result is the spider diagram that provides an insight into the impact of each of the indicators on profit and NPV. Two tabs are also available for the analysis: General and By Final Products. The indicator with the highest impact is considered the most attractive for optimization. Its changes have the most significant impact, and any positive influence on the indicator will lead to the most satisfying economic effect. We also added the functionality to estimate an external final boundary unrelated to the existing product. This makes it possible, for example, to estimate an existing field development boundary or evaluate a resulting design. The estimation will use economic and other indicators you entered when you created the optimal boundary design. You can download the data into Excel for a more detailed comparison. You can also record the affiliation of the blocks within an external boundary to a field of the block model. In the same way, you can record the affiliation of a certain type of pushback blocks to the block model. This applies to both auto pushbacks and manual pushbacks. This function makes it easier to display the part of the block model you want to see. It can also be used in the scheduling module to define mining areas. Now, let's go back to the new feature we talked about at the beginning: exclusion zones. The idea behind this function is that the specified area will not be mined in any case. It will not only decrease the result by this area, but also take into account the need to mine the blocks of the whole area, making it impossible to mine unnecessary blocks. The process is very simple. We draw a closed polyline, place it in a separate layer, and select it in the plugin field. That's all. The data is accounted for. There can be many such zones and zones with capital costs. Enter the parameters and enjoy the result.